Alright, let's tackle this set equality proof. Now recall, when you want to show that two sets are equal, you need to show two things. We will need to show that A cross B intersect C cross D is a subset of A intersect C cross B intersect D, and we need to show the other one, that A intersect C cross B intersect D is a subset of A cross B intersect C cross D. So once we have shown both of those things, we can conclude that those are equal. Alright, so starting with the first one, we're going to attempt to show that A cross B intersect C cross D is a subset of A intersect C cross B intersect D. Now remember also, when we want to show that one set is a subset of the other, we take an arbitrary element in the first set. So we're going to say so our elements here are ordered pairs, right? Because we're looking at the Cartesian product. So we're going to let xy be an element of A cross B intersect C cross D. And our goal is to show that that element, that ordered pair xy, is in this right side. Alright, so what does it mean for xy to be in A cross B intersect C cross D? Well, it means that xy, this ordered pair, is in A cross B, and, that's my intersection, it's in C cross D. That's what it means to be in that intersection. Well, what does it mean to be in that cross product? Well, if xy is in A cross B, this means x is in A and y is in B. Now we have this and as well, so what we also have is and x is in C and y is in D. That's what xy being in C cross D means. So now I can rewrite some of these things so that I will be able to conclude what I want. So I have x is in A and x is in C. That means x is in A intersect C. And I have that y is in B and y is in D. So y is in B intersect D. So if x is in A intersect C and y is in B intersect D, this means that xy is in A intersect C cross B intersect D. And that means that the left-hand side is a subset of the right-hand side. So we have successfully shown 1. Alright, now we need to show 2. So I'm going to move to a new board. And our goal, let's say what we need to show here, or our goal so that we see where we're going, is to show that A intersect C cross B intersect D is a subset of A cross B intersect C cross D. Sorry, D. Alright, so just like before, we're going to take an arbitrary element in the left-hand side. So our elements over here are part of a cross product, so let xy be an element of A intersect C cross B intersect D. Well, what does that mean? That means x is in A intersect C and y is in B intersect D. So this should start feeling familiar to you because we're really unraveling what we just did on the other board. Alright, x in A intersect C means x is in A and x is in C. And y in B intersect D means y is in B and y is in D. So now let's rewrite things in the order that we want. We have x in A and y in B. So this means XY is in A cross B. And we have X is in C and Y is in D. So that means XY is in C cross D. So if XY is in A cross B and it's in C cross D, this means XY is in A cross B intersect C cross D. And so we have successfully shown two. We have shown that the left-hand side is a subset of the right-hand side. And since on the previous board we showed that this right-hand side is a subset of the left-hand side, we can conclude that the two are equal. That is, A cross B intersect C cross D is indeed equal to A intersect C cross B intersect D.